Hi, I'm Doug with Weatherford, and I'd like to share with you why we run centralizers and how you can choose the right centralizer. You might ask yourself, why run centralizer? Centralizers keeps your casing centered in the hole or parent casing so that cement can flow over the entire annulus. When your cement is set in the right places, you can achieve an effective cement sheath that promotes wellbore integrity. Here you see a sample of 5 different centralizer designs. All of these for 5.5-inch casing to be run in 8.5-inch open hole. They represent 2 families, bowspring centralizers and rigid centralizers. Let's go through some of the differences among them. Centralizers with a bowspring design like these 2 are very common. They have welded and non-welded bowsprings. When these bows are pushed against the wellbore, they push back to help center the pipe. Important considerations when selecting a bowspring centralizer are the running forces and restoring forces. The running force contributes to the drag forces when running casing into the well, and the restoring force dictates the centralizer's ability to overcome forces pushing the casing off center. This centralizer has been the workhorse of the industry for many years. It has several welded bows. You should look for welded bows that use an automatic welding process that gives you a weld consistency. This centralizer has a hinge that can latch around the casing or coupling or stop collar that pulls the centralizer into the wellbore for ease of running in the hole. The hinge design itself is folded inward to be supported against the casing that makes it more robust and stronger. The ridge here is pressed into the end band that creates a stronger end band and thereby a stronger centralizer, and also guides the centralizer through any restrictions and ease of running. These centralizers are typically used in vertical and deviated wells. This style of centralizer is particularly useful in open hole sections that can be oversized because the bows are normally larger than the planned hole size. The Variform centralizer is a single-piece centralizer. The manufacturing process allows for a 3-dimensional shape to achieve optimum performance. As you can see, the bow width and the curvature can vary, as well as the OD and the length. This type of centralizer is available in 2 styles, one for passing through restrictions and opening up into an under-ringed hole section, or standard Variform. In this case, the centralizer OD is the same as the drill hole ID, thereby providing maximum standoff and 0 running force, while also providing the flexibility to pass through restrictions. This design uses a proprietary joining process that is indistinguishable from the base metal. The centralizer is run between stop collars and is great for rotating applications. Because of its single-piece construction, the Variform centralizer has full traceability. Rigid centralizers like these 3 have blades that don't flex under downhole conditions. This makes them rugged enough for highly deviated and horizontal well bores. Because their OD is smaller than the well bore, there is some sacrifice in standoff. These types of centralizers are also good for rotating applications. The Spiral Glider centralizer is the most widely used rigid centralizer in the world. It has rounded, hollow blades made with a controlled welding process. The blades glide smoothly and minimize drag forces. The spiral blade will also create some turbulence to optimize mud removal and displacement during cementing. This feature makes it suitable for vertical, inclined, and horizontal wells. Also, the hollow blades are designed to collapse if the casing becomes stuck in a restriction. The composite centralizer has tapered blades and is lightweight compared to some metal rigid centralizers. These centralizers have a lower coefficient of friction than steel centralizers. These work well in extended reach and highly deviated wells. The buyer should be careful when selecting a composite centralizer that the impact loading and wear characteristics of the material are clearly understood. This centralizer has blades welded to the exterior of the body for a completely solid construction. Although the blades are angled to help mud flow around the centralizer, notice the sharp edges on the blades and the aggressive angle, which could cause excessive drag. These centralizers are quite heavy as well. I'm not a big fan of this design, but they are commonly used. I hope you found this explanation useful. If you'd like more information, please visit our website to see our centralizer application guide or call your local Weatherford well construction representative.